Welcome to this second inaugural webinar to the Iliad Hackathon. My name is Bente Liljaby. I'm going to be your host of this webinar as well, as I'm for the Iliad webinar series. But today we have a specific topic. We want to introduce the second theme of the Iliad Hackathon, which is fusing generative artificial intelligence with digital twins. And we have a couple of experts that will introduce you to the topic in general, but we also will, of course, let you know more details about the hackathon itself. And in order to start right on it, I will give the floor to Tom Red from Hobocean. Hobocean is leading this hackathon. And Tom, we are excited to learn about this specific theme of the hackathon.
Yep. So hello, everybody. I will do a very quick introduction about the Iliad project first. So Iliad is an EU-funded digital twin of the ocean project, and it's in its third year now. And we're organizing as part of the project a hackathon this year. So there will be a virtual hackathon starting at the end of this month, running until September, where we'll have a physical event in Oslo. We have three themes for this hackathon. The first is digital twins in action. So that's people showing how to build digital twins. The second theme, which is the topic of today's webinar, is AI and specifically large language models and their interaction with digital twins. And the third topic is about interoperability and how different digital twins can connect to each other. So today, it's a really exciting webinar introducing the topic of the interaction of large language models interacting with digital twins. I'm really excited that we have this as a topic. It's obviously, if you've had to have been living under a rock for the last few years if you haven't seen the huge amount of interest that's been generated by these new generative large language models. And so we really wanted to see what we could do in integrating those kinds of tools to the digital twins of the oceans that we've been building as part of the Iliad project. So we're joined by a colleague from an organization called Sintef Ocean in Norway. Sorry, Sintef Digital in Norway, Francisco Martin Recuerda. Apologies for the pronunciation. Francisco's been working on LLMs for the last few years. Well, since they've really, well, probably longer than that. And he's going to give a little introduction to the topic today. And we unfortunately we weren't able to, the other speakers weren't able to join us today, so we'll probably keep the session a little bit shorter today and then have a follow-up one on another time and go into the topic in a little bit more detail. So I'm going to hand over to Francesco. I'm going to put more information about the hackathon in the chat and also a link where you can sign up. I'll give a little bit more details at the end of the webinar. So over to you, Francisco. Looking forward to this.
Thank you, Tom. Can you see my slides?
Yes.
Yeah. So welcome everyone to this webinar. This is a high-level presentation, just an introduction to LLMs and in the context of digital twins. As Tom said, my name is Francisco Martin Recuerda. I work at senior research at Sintef Digital in Norway. Sintef is one of the largest independent research organizations in Norway. And my background is in artificial intelligence, symbolic AI, like knowledge representation, semantic technologies. And also, as Tom said, in the last few years, I have been working also with generative AI, and particularly with large language models. So first thing is just basically to put you a bit in context. There are really a different interpretation of what a digital twin is, but in short, basically a digital twin in this particular context in the ocean, which is actually what Iliad is trying to build in the project, aim to provide a virtual environment representing the ocean and capable of running complex predictive and management scenarios. So basically, this is a very powerful tool for scientists to basically try to create, for instance, if scenario. So if I have this type of conditions, which is actually what will be the situation, basically, I will find out. And actually, this is actually what I am expecting based on the prediction I made myself. So these type of systems are very complex and integrates many things like sensors, models, and digital infrastructure. So here in this presentation, I will emphasize that complexity is the key. So this is another picture of basically what the Iliad project is aiming to achieve. So again, this is you will have multiple application services that basically try to help you to prepare your data to basically do analytics or do simulation. You will have also analytics service ready for you to basically play with that or basically use it for your research. You will have complex modeling service. And of course, we will try to make ourselves as much integrated with other platforms as possible. So this is the idea of introducing this concept of ocean data spaces. So this is basically in a very high level what kind of service and what is you expected to find in a digital twin like the one that Iliad is building. But you are, in most of the cases, you are just a researcher that basically maybe on the specialized in biodiversity. You are not a computer engineer. You are not a database engineer. And basically, you are facing the complexity of how to deal with this very complex infrastructure. And of course, you have typical needs, no? So you need to find data. You need to find the algorithms that have been created by the community and have been stored and deployed in these complex applications. You have ready-to-use applications that basically you would like to introduce or use in your research. And you need to find this information. You need to access to this information. And also maybe perhaps what you find in the digital twin is not what you need. So you need to basically implement modifications of the data on the algorithms in the applications. And then, of course, you need to operationalize the experiments you wanted to run. And for this point, you try to create data or ML machine learning pipelines to basically put all the data that you need, basically do the transformation you need, execute the applications of algorithms you need, and get the result you are hoping to get. No? And then, of course, a very important thing is how to interpret the result of the experiment you execute and how to visualize this data. And there are many other things as a researcher you need to know. But at the moment that if you face a typical digital twins infrastructure, you will have to basically cope with all this complexity, and you have to become a little expert on databases in SQL, query language, or you have to get a bit of expert in Python, and you need to get a bit of expert on a specific type of application, APIs, and many things. And basically, this is requesting a huge effort by researchers. So moving to the Hollywood wall, you probably have been seeing this movie, Iron Man, and this is Tony Stark, the person who basically characterized Iron Man. And what is most interesting about this movie is that he has an AI digital assistant, really super smart. It's called Jarvis. And Jarvis was capable basically to interact with Tony Stark by just exchanging information and orders in natural language. So, and Jarvis was capable, based on this natural language understanding, to basically complete very complex tasks for Tony Stark. Now, so basically, this was a system that is, of course, still science fiction, but we are not far from there as we thought. That basically is capable, as I say, to understand natural language. It's able to solve very complex problems. It can actually apply some human-like reasoning. He has broad access to knowledge. So the full internet was accessible for Jarvis. And also they support multiple interfaces to interact with Tony Stark, including voice recognition and many more other things that basically this assistant was able to cope. So basically we are thinking in this complex infrastructure of digital twins, is having something similar to Jarvis will be actually interesting. And the question is, do we have something similar to Jarvis? And the thing is that it's not as sophisticated as that, but At the moment, there is a huge effort in the industry to develop what they call it large language model, or now foundational language models. So basically models that basically are capable to understand natural language commands, that they can solve very complex problems. So it's not just basically a smart translators or smart text summarizations tools. So they are actually able to solve more complex problems or multi-purpose problems. In fact, they are able to apply some sort of human-like reasoning, like Jarvis was able to do, and they are trained basically with the full or a big part of the internet. So basically, they have broad access to knowledge, to the knowledge that basically we have available also for ourselves. And they also support multiple interfaces like voice recognition, chat interfaces, and so on and so forth. So, and this is a kind of very active line of research and also very active production line for big AI tech companies like Microsoft, Google, Meta, or OpenAI. So the thing is that this is basically the new versions are getting more and more smarter, and they are more capable to achieve very complex tasks. So the question is, so you wonder, okay, so these technologies are fantastic, but how I can actually adapt LLMs for digital twins? And I would like to emphasize that, of course, I will not go into the details of basically everything you have to do, but I would like to bring to start with a common misconception. That is basically, in order to adapt this large language model or these foundational language models, the thing you have to do is just fine-tuning. So this is basically the conception that many people have, that you just solve the problem of adapting these LLMs to a specific task you wanted to complete by fine-tune the model with the specific data you have, with the specific commands and tasks you have to solve, and that is basically the approach. But I think that this perhaps was true on the old models, old model maybe 2 years ago, so this is not really old, but the new models basically are smarter than that. And actually, there are a few issues when you try to do fine-tuning without knowing how to do fine-tuning. So this is basically from a wonderful slide from OpenAI that was presented in the Open Dev Day last year. So people interested in this topic, I strongly recommend you that you watch some of the videos they provide. And basically, they were talking about this situation. So basically, they have a customer. They ask them to basically fine-tune GPT 3.5 with 140K Slack message in order to basically make the model more keen to basically have this kind of slang, more informal way of communicate with users. And then after this effort that is very costly to make, particularly if you're using closed models that are run it in their own infrastructure, because you pay by words that basically you send to the system. So they just test the model, no? And say, well, okay, well, we have this thing. So what is actually the result? So they just write this simple command, write a 500-word blog post on prompt engineering, and basically a reply of this fine-tuned model was, sure, I shall work on this in the morning. So the thing is that basically they got actually also this kind of loose way of reply based on this Slack message. And then basically that was not what they were expecting. So they invest a lot of money. They tried to adjust the model. Basically, what the result was not what expected. So fine tuning is a very powerful technique that basically you can use for improving the performance of LLMs, but it's not the only technique, and usually it's not the first technique you have to consider when you try to adapt the LLMs to basically to be used in your application or be integrated into digital twins. So this is another really nice slide from OpenAI, also provided in this Dev Day OpenAI that was organized last year. So basically, you can categorize main techniques into 3 main topics. One is called prompt engineering. So prompt engineering is just basically learn how to provide instructions to the LLMs, to the language models. So I think that there is a misconception that basically people are missing this part a lot, and a lot of the frustration you get when you don't get the replies or the expected output that you think from this model is because you don't really understand these techniques. So because you don't really understand these techniques and you basically think that the model is failing at providing the answer you wanted, that is why you go directly to fine-tuning. But this is not actually how you have to start. You need to start learning how to interact with this model. You have to understand that the way that basically you command this model, the information you provide in your commands, that really make a difference and can improve substantially. Sometimes you can improve the accuracy more than 50 or 60%. Just by basically using the right prompt engineering techniques and by basically creating the right commands to basically instruct the model about the task you wanted to solve. So after doing this thing, after applying different prompt engineering techniques, I will not cover in this short webinar, you are not fully satisfied, then there are two considerations you can make. So the first consideration is the problem you have in order to improve the result is because the model needs more context. So you have to basically understand that these models are trained usually in very broad knowledge, but this broad knowledge maybe is outdated because this was trained perhaps the last year, or maybe it's not the knowledge that basically, or information that is related to your domain of expertise or the domain of expertise of the digital twin you are building. So in this case, there is this technique called RAG, Retrieval Augmented Generation, that basically the idea is that you connect a database, usually a vector database, to basically provide additional information to the model that you can use to enrich the capability of the model to basically provide update information or update answer or answers that are related to the context or the domain expertise you are interested in. The other thing that basically is what we discussed already, fine-tuning. So basically here is just basically we are trying to adjust a bit the behavior of the model or the way that basically they provide answer to the question or the task you wanted to solve to basically be more close to what are your expectations. And of course, RAG and fine-tuning are not basically exclusive. So basically you can combine both. That is actually, you can augment the context or the information available for the model, or you can adjust how the model behaves. But as I say, fine-tuning is a bit tricky. Particularly with closed model, you don't have access to the internal variables of the model. So basically, sometimes you might have unexpected behavior of the model based on basically how you do the fine-tuning, or even you can make the model worse, so basically be less accurate or basically be incapable to solve other type of tasks. So the thing is that fine-tuning, you need to understand what you're doing, the same way that from prompt engineering, you need to understand what you're doing in order to get the best of the models. So a few tips for you in case that you wanted just to use LLMs for your digital twins or for your applications. So it is important that in order to tune the capabilities of the model or to basically to optimize the response of the model, you need to be systematic. So the idea is that basically you have some features that you wanted to incorporate into the model in order to improve the performance. So don't do it everything at once. So just try one feature at a time and try to evaluate the impact just to see actually the feature you try to introduce actually improve the capabilities or not. The other thing is that you need to have a good evaluation or test bed that basically help you to understand it, to measure your progress, because sometimes you try a couple of prompts just to basically see if you are getting better, and maybe that is not enough. Maybe you were just lucky with these prompts, and that is not actually a way of make a proper assessment of basically of the progress. So you need actually to create this type of evaluation or use evaluation that are available, created by the community to really measure your progress. So as I say, start always with prompt engineering. Don't go to fine tuning. If you don't understand how to interact with the model, basically it's a mistake to basically try to fine tune the model and force the model to behave as you want it because you don't understand how to interact with the model. So this should not be the way. So work with a small, medium data set for exploratory purpose to basically try to confirm to basically just play with the model and try to figure it out which feature works well or which kind of instruction work better, and then basically try to have a larger test set that basically you can do to confirm that your findings are actually findings and not just basically an effect of luck. And of course, after completing your prompt engineering experiments, trying to evaluate, you need to apply RAG or fine-tuning to basically improve your model even further, right? And work on iterations and reconsider your approach if the results are not as expected. So sometimes LLMs can be very frustrated because you try to apply common sense, and this model doesn't always follow your common sense. So the way that basically they behave are probably not as you expected. So be aware of that. And then, of course, if you are using a closed model like OpenAI, the GPT, it's you quickly go into very high bills. So basically, you have to monitor your experimentation cost. So last slide from my side, where I wanted just to bring the topic of open versus closed model. I put open, but this is not really open because basically the binaries of this open model are not available. The training data set are not available. So the only thing that because they call open is because you can run it in your on-premise or cloud infrastructure, but they are not open at all. So that is basically the difference with closed models. So open model will be Llama 3, will be Mistral. Closed model will be Claude or will be GPT. But as I say, open are not really open. So pros of closed models, so GPT or Claude models. So the pros or the positive things of this one is that you can quickly prototyping and you can easily deploy applications and prototype because you don't need to create an infrastructure for running this model. OpenAI, they basically provide, for instance, for you. They are very high quality models. So at the moment, the state-of-the-art models are basically closed models. So the open models try to approach them, but the tests basically and our experience show that basically there is still significant differences. And of course, you don't have to provide, because you don't have to provide an infrastructure, there are no fixed costs. So as much as you use it, as much as you pay. So pros of open models. So you have less privacy concern because the model can be run in your own infrastructure. You have a better control of model performance because basically you have more accessibility to certain parameters and configuration parameters that you don't have in closed models. And then, of course, you have a bit of more flexibility of adapting and choosing a model because basically, as I say, you can run it on your premise. You maybe have access to some configuration parameters that you don't have in closed models and so on. What are the cons of a closed model like GPT or Claude or Gemini? So there are, of course, privacy concerns. These models are run in the cloud infrastructure of the provider, many of them in the US. So for instance, GDPR and other type of EU regulation doesn't apply there. Then you have some problems in terms of latency and ability because basically you interact via an API and sometimes the response you get is not as fast as you expect. So basically just the infrastructure is so busy with all the requests that basically your requests take a lot to basically get a reply. And then they are very costly when you try to scale up into a production solution. So that is basically a thing because you basically pay by the number of requests and information in the request that basically you are sending by the APIs. So cons of open models, basically you have fixed base costs. So basically you need to set up an infrastructure in many cases to really run these models and fine tune these models. So some of them can be run in your laptop, but of course, in order to get certain performance, and particularly you wanted just to work with the big ones, then you really need a specific type of GPUs, which are, if you try to buy one these days, you will have to basically wait in a very long queue to basically get one. And they require to set up this infrastructure, which is not for everyone. So basically you need IT specialists to basically set up the infrastructure, the execution infrastructure for you. And of course, they are still a bit behind in terms of performance of open models, of closed models. So that is basically a thing. So sometimes maybe you don't get the answer you wanted. You try with a closed model and then you get what you want because still the differences are significant. So this is, in short, what I wanted to tell you today in this webinar. We'll be very happy to answer any questions or discuss about any comment you might have. Thank you.
Excellent, Francisco. There's a lot. There's a lot to benefit from in terms of technology here for digital twins, obviously. Would you say, well, first of all, I noticed one thing that I wasn't aware of, and that was that the most interesting part of the Iron Man was the Jarvis. I was not aware of that. I will quote you on that, Francisco. Are there any questions? I would really like to encourage the participants here to ask questions. You have the possibility to learn about more about artificial intelligence, and also learn about, by all means, also ask about the hackathon itself. But there will be more information about it. But questions for Francisco now would be a good opportunity for you to use to ask. I don't know if I see anybody in the chat that is asking. We have provided more links to more information about the hackathon itself, and we have also provided a link to sign up for this. But Francisco, is this, you know, the artificial intelligence, the many different types of, or components of that, if you like, have you seen that being used in many applications, in many practical, you know, twins in this case?
Well, I think that yes. So as you say, there are many type of artificial intelligence that we didn't introduce here, but generative AI is getting a very powerful application to basically a very powerful tool as a digital assistant for engineers. In the particular case of Iliad, for instance, we are trying to use generative AI to basically, or a large language model to facilitate data integration and semantic harmonization in Iliad. No? So basically, you get a lot of different type of data sources that are quite different represented, different schemas, different vocabularies for that. And basically, one of the good things that Iliad provides is this referent schema and referent terminology. It's called the Ocean Information Model that basically aim to facilitate that the data look the same, no matter where the data come from. And of course, there is an important manual effort of trying to basically harmonize, or basically change the way that basically the data it had been represented in origin to how this will be stored and make it available in Iliad. So this process actually are now, we are investigating how to support this process to use this type of technology. So can we basically use this smart assistant to help us identify how to basically do this harmonization, how to transform the data properly in order to make it compliant with the Ocean Information Model and to the Iliad partners and any other type of user that are interested to use the Iliad Digital Twin infrastructure. So this is, for instance, will be a typical example we are currently exploring in Iliad.
Oh, that's great. And that's a great, you reminded me of an important point, and that in this hackathon, we will work, we encourage the pilot leads and the pilots within Iliad to further develop their pilots. And there's room also for externals to join that. But in the hackathon, you can also create your own pilot or twin, if you like, and benefit from the technology developed in Iliad, right, Francisco, what you just mentioned. So there's lots of possibilities here to experiment. I see that Eva has a question. Eva, do you want to take the floor and ask it?
Yes, thanks very much, Bente, and thank you, Francisco, for a very interesting presentation. I just wanted to ask, in your experience, have you used more open or closed models? You know, I feel like cost often comes into this. So as much as we'd like to quickly prototype a language model, sometimes open models are more practical in terms of thinking ahead towards it becoming operational? And also, you mentioned semantic harmonization with Iliad. Do you see an open or closed model, I suppose, architecture in that case, and or even maybe training your own neural network? Sorry, there's kind of two questions there.
No, it's okay. We are happy to answer as many questions you have. I think that so I try to bring this topic because I know that this is a fascinating point of discussion for people. So they are really strong supporters of open models, which, as I say, they are not really open. So be aware that what is open is not really open. The only reason that they call it open is because you can basically deploy these models in your infrastructure. But this is by no means that really open. So you don't have, for instance, access to the source code or basically of this model have been implemented, and you don't have the possibility to access to the training data that basically they have been used to basically be trained. So the only thing you can do is to make a few adjustments via fine tuning or via RAG, as I discussed. So at the moment, I think that I will advise in general researchers who are interested to start playing with this model to start with closed models. And the reason for that is just because the setting is very simple. The only thing you need is to learn how to write commands. So basically how to interact this model via the API, which are actually quite simple to use. And then, of course, you can basically play around with the models. And then as soon as you are considering seriously to go into production, then maybe you can actually try on with open models. But as I say, that's required for you to have somebody assisting you on setting up the infrastructure and setting up these models. And if you need to do some sort of fine tuning, also that is not for everyone. So again, I mean, you have already experience working with deep learning. That, of course, help a lot of training deep learning models. But as I say, we are talking about models that are beyond the size of any deep learning model that probably an average researcher have been trained. So some cases we are talking about hundreds of billions of parameters, basically. So this is actually very huge models. But as I say, my advice is start with a closed model, experiment with them, get to solve the problem you wanted to solve using this model, except is the data you are using is so sensitive that basically you cannot put it in the cloud infrastructure. Then the only possibility is to use open models. Did I answer your question?
Yes, thanks so much, Francisco. And sorry if you don't mind me asking as well. You know, a model is only as good as the data it's trained on, and I suppose with fine tuning as well, there's a lot of pre-processing involved. You know, when you talk about a vector database, in your experience, do you find, you know, when it comes to fine tuning, possibly, and like you said, that's maybe not the first port of call, but do you find there's a lot of pre-processing involved just to, you know, start fine tuning your model?
Yes, this is a very good question as well. So the thing is, yes, I mean, this is actually the tricky part that nobody explained you. So, I mean, if you are used to train deep learning models, you know that basically you have to create high quality data. This data could be, should be labeled data. So that is in order to basically test that you are providing the right examples to the model in order to basically learn what you wanted to learn from them. So we move from basically something that is fully unsupervised into something that is more supervised or semi-supervised approaches, which are more costly. And that is actually a big issue. Get this good data, this data of high quality, label the data properly, and basically apply fine-tuning techniques that are not just basically just throw the data into the model. So you need to basically separate what is the test data to this is training data, and basically also learn about how to adjust the way that basically this data is input into the model. So there are a lot of things. There is another aspect that, as I say, it's also very important, which is actually having your test settings. So basically, in order to do proper validation of your progress, you need to basically create your test setting, even though you don't want it to do fine tuning. And also getting data and prepare this test setting also is quite involved. So it requires a lot of effort. So it's not something that people think that so it's not, unfortunately, we are not in the Jarvis phase yet. So you still need to do quite some work in order to get what you want from them.
Thanks, Francisco.
Thank you very much. I don't see any more questions. Raise your hand if you have. I see there's some comments here, and Arne Jørgen Badde from Sintef has pointed to some more resources, some more information from Cognite specifically. We had almost somebody to come from Cognite, but they couldn't make it in the last minute. But there's definitely some resources and more knowledge there. As Tom will now say some more details about the hackathon. By the way, Francisco, can you unshare your screen, please? Yeah. So you will learn more details about the hackathon, but as was mentioned in the chat here, there's a lot of educational webinars planned for inside this hackathon. So there's a possibility to learn more as a participant here. But Tom, I'm getting ahead of myself. You can take the floor.
Fine. Thanks, Bente. Yeah, just wanted to round off the session. So Francisco, thank you for giving that introductory talk to use of LLMs and their interactions with digital twins. I think this is a topic which we can unpack a lot more in the webinars in the hackathon, and we can give some practical examples going forward as well. I think that would be really nice. And you've already kind of promise that you'll do something there, so we're looking forward to seeing something more hands-on that people can maybe use in the hackathon and get going with their own digital twins as well. So Bente has provided a link to the registration and the more information about the hackathon this year. Just to reiterate, it will be a two-stage hackathon with work on starting towards the end of this month on a online, so virtual hackathon, and then we'll have a physical event in Oslo in September for a few people, not everybody. So the virtual hackathon is open to anybody to join, and then we'll have a smaller event in Oslo where people can come and do the final hack and the presentation of the projects. So just a reminder that the three themes are digital twins in action, fusing GenAI and digital twins, interoperability between digital twins. So people forming teams will be able to choose what kind of focus area they do. It's open to people from the Iliad project and also outside, and we'd quite like to have the teams being a mix of people from Iliad and people from outside of Iliad, so that we can kind of really use the components from Iliad that have been developed outside of the project as well. And yeah, that's that. Tomorrow we have a webinar talking about interoperability. It's in the afternoon. The details for that and the registration are also on the website for the hackathon page. So if you're interested in learning more about interoperability, we have three really interesting speakers. Again, some from the Iliad project, some from outside the Iliad project. So you're all very welcome to join that. I think I'll wrap it up today. If anybody has any questions, my email and details are on the website as well, and we look forward to continuing this webinar series.